All right. Hey everybody. So we're going to start this video with solving another polynomial equation. We're going to go through those steps from yesterday, and then we are going to create our own polynomials given the zeros of the function. So let's get started with this first one. We have p of x equals x to the third minus 3x squared plus 9x minus 7. So let's go through our steps from our tree map that we talked about yesterday. So step one says graph it. Look for where it crosses the x-axis, which are our zeros and our roots. So I've already typed this in Desmos, and I already graphed it, and I found that 1 is where it crosses the x-axis. So type it in Desmos, and I got 1 from Desmos. So check there. So that's the first step in doing this problem. Now, let's see what the next thing it tells us to try. After we graph it, it says do synthetic or long division. I highly encourage you to do synthetic division. What we get from the calculator goes in the box. All right? So if I got 1 from the calculator, that's going to go in the box when I do synthetic division. So 1 is going to go in the box. We're going to line up our coefficients. 1, -3, 9, and -7. I don't need any placeholders. It goes x to the third, x squared, x in my regular number. We draw our line, and the 1 comes straight down. From here, we multiply, add, So multiply, add, multiply, add, multiply, add. Again, this number here should be 0 because we got a solution. We got a root. We got a 0 from the calculator. So this number should be 0. My problem started x to the third, so my answer is going to start x squared. So this is going to be x squared minus 2x plus 7 equal to 0. All right, so far, so good. Now let's see what else it has to say on our little thinking map that we did from yesterday. So we already graphed it, check. We just did synthetic division, check. Factoring. I do not need to factor this problem. I cannot factor this problem. I know I can't factor it because 1 is the only solution that I got from the calculator. Everything else is going to be imaginary. So if it's imaginary, you can't factor it. So factoring isn't going to help me. And the last thing, the use substitution, I do not need to use use substitution, because this is x to the third, and you only do that with x to the fourth. So that leaves us to solve the remaining quadratic, either by doing quadratic formula or completing the square. Now, I did a quadratic formula yesterday for those of you that like to do that, but I'm going to go through and review completing the square today because that is an important skill to make sure we know how to do. So when you complete the square, this number has to be a perfect square number. It's not. We're going to move it over to the other side. So x squared minus 2x, leave a little space, -7. Off to the side, I always encourage you to write your 2 steps from when you complete the square. You take half of the middle number. Half of -2 is -1. And then you square that number. -1 times -1 is +1. You add this number to both sides of your equation to keep your equation balanced. From here, we factor it. 2 numbers that multiply to give me +1, add to give me -2. That's x minus 1 squared. -7 plus 1 is -6. If you write out your steps, number 1 will always be what it factors into, which is why I strongly encourage you, if you are not in that habit yet, to make sure you go ahead and you write your 2 steps out. From here, we're going to square both sides. So it's going to give me x minus 1 equals I, and don't forget plus or minus, square root of 6. So there was a negative in here. You pull that out, you make that I. When you take square root, it's plus or minus. So this is plus or minus in there. We're going to add 1 to both sides. So our final answer is 1 plus or minus I square root 6. So now we have all 3 answers that we're looking for. And I know I'm looking for 3 answers because my highest exponent is 3. So my 3 answers to this problem are 1 plus I square root of 6, and 1 minus I square root of 6. And let's list out how many and what type of solutions we have. We got 3 zeros, roots, x-intercepts, solutions. They all mean the same thing. There's 3 of them. 1 is real, and 2 are imaginary. So that was an additional problem from yesterday in case you needed some more practice to look at as you're working on your assignments. Now, what else can I do with that? Well, I can do something like this. So I can write a polynomial function of least degree with integral coefficients that has the given zeros. So let's decipher through some of these words that are in here. Polynomial. They want us to make up a polynomial. F of x equals x squared plus 3x minus 7. Or f of x equals 5x to the 4th minus 2x plus 10. We are creating the function. A function passes the vertical line test. Degree means we want it to be the smallest exponent that it possibly can that meets the criteria. Integers means no fractions or decimals, and zeros. So they're giving us the zeros and we are creating the function. So we're working backwards. They're giving us the zeros, we are creating the function. So let's start with a basic one before we try one that's a little bit harder. Say they want us to make up a function that has zeros at 2 and negative 5. This means when you graph it, we want it to cross at positive 2 and negative 5. So we're going to have to work backwards. We're going to need to write these zeros in factored form. So in factored form, it's the opposite. So this is positive 2. This is going to be negative 2. And if that's negative 5, it's going to be positive 5. We go through, we multiply this out using box method or distributive property. I'm going to distribute. That gives me 5x minus 2x minus 10. Combine like terms. And voila, we have just created a function of least degree that has the given zeros. So if we were to graph this, x squared plus 3x minus 10, if I were to graph this, it's going to cross at positive 2 and negative 5. Now, let's step our game up a little bit. Suppose they give us zeros of negative 3 and 4i. So suppose they give us zeros, negative 3 and 4i. Imaginary numbers come in pairs. So this 4i will never just be by itself. What goes with 4i is negative 4i. So it's called a complex conjugate. So if one is positive, you have to include the negative. If one is negative, you have to include the positive. So imaginary numbers will never, ever, ever be an odd number. It'll be 2 of them, 4 of them, 6 of them, 8 of them, etc. You'll never just have one of them. The buddy has to come with it. So these are called complex conjugates. So when I set this up in factored form, I'm going to go through and do the exact same thing. This is negative 3, so in factored form, it's going to be x plus 3. In factored form here, it's going to be x minus 4i. And in factored form here, it's going to be x plus 4i. Okay, same thing I did over here with this real solution, the one that was giving us real roots, except for now I do have an imaginary root in it, and that's okay. I actually have 2 imaginary roots in it. Now we're going to want to multiply this out. When you multiply this out, do the imaginary part first. Do not do these 2, because you're going to have some mixture of real and imaginary, and it's going to make your life 10 times harder. So do not do the real and the imaginary. Go ahead and multiply the imaginary part out first. You can multiply that out by using box method or distributive property. It makes no difference to me. So when I multiply this out, okay, I'm going to do distributive property, okay? X times x gives me x squared. Okay. X times this is going to give me 4ix. Negative 4i times x is going to give me negative 4ix. Negative 4i times 4i is going to give me negative 16i squared. Okay. Positive 4ix, negative 4ix cancel each other out. Cancel, cancel. So this now gives me x plus 3 equals x squared minus 16i squared. Now, I know that I squared gives me negative 1. So I squared gives me negative 1. So now this becomes positive 16 because I squared is a negative 1. Negative 1 times negative 16 is a positive 16. So now I have x plus 3 times x squared plus 16. Because I squared equals negative 1, 2 negatives make a positive. From here, I can go through, do distributive property, box method. Makes no difference. You do not have to do both ways. Just do whatever you feel comfortable with. I'm going to do distributive property. X times x squared is x to the third. X times 16 is 16x. 3 times x squared is 3x squared. And 3 times 16 is 48. And this parentheses here was not needed, so I'm just going to scribble that out. I didn't need that parentheses there. So I went through and I did distributive property. If you want to set up a 2x2 box, you are more than welcome to. We're going to get the same answer. Last thing I need to do is put this in order from the biggest exponent to the smallest. So it's going to give me x to the third plus 3x squared plus 16x plus 48. And this is our answer. So this polynomial, when I graph it, would have roots of negative 3, positive 4i, and negative 4i. So we are working backwards. Yesterday and in the first problem today, I gave you the polynomial. You went and found the roots. Today, I'm giving you the roots, which are the same as our zeros, our solutions, and you're multiplying it out to find what we started with. And don't forget, imaginary numbers come in pairs. Oh, and if I were to list this out, of course, we'd have 1 real, 2 imaginary. And this one had 2 real solutions. Okay. I'm not going to go through the whole number 3, but I will at least set it up for you because distributive property box method, we've been doing that for a while. So I will at least set it up for you. So I know if this is 4 and this is negative 2i, imaginary numbers come in pairs. So we're not going to have just negative 2i. We have to include 2i as part of our solution. Okay. So if I set this up in factored form, it's positive 4. So in factored form, it'd be x minus 4, and etc. and so on with the next one. So this is going to be x plus 2i, x minus 2i, and you would multiply all this out. So I'm not going to multiply it, but I will yet again let you know that you need to multiply the imaginary pieces first. Do not do the real times the imaginary. Go ahead and multiply the imaginary part first because some stuff is going to cancel and it'll make your life easier. So I'm not going to finish this up, multiply, box, distributive property. Last one, number 4. Okay. Say I want to create a polynomial that has roots negative 2 and 3 plus I. I still need to include the buddy that goes with 3 plus I. So I need to include the complex conjugate. So negative 2 is a real root. 3 plus I is an imaginary root. We need to add 3 minus I. So you do not change the sign of the real part. Think back to when we were multiplying imaginary numbers and things like that. You only change the sign in the middle. So if it's plus I, we have to include the negative I. If it was negative I, we'd have to include the positive I. So 3 plus I and 3 minus I, we call those complex conjugates. Now we go through and we set these up in factored form. So this is going to be x plus 2. When I do the next one, it's going to be x minus 3 plus I. And then the next one is going to be x minus 3 minus I. Now, I'm going to go ahead and just prep you. This is kind of a hard one, but I am going to go through it and do it with you together. So it is kind of a harder problem. So it's okay if you do not get it right away. So that's okay. Nothing wrong with it. So we're going to go through and we're going to multiply this out. So we're going to multiply it all out. When I multiply this out, I'm going to put the real parts of the problem together and then the imaginary parts of the problem together. So this x plus 2 is just going to keep hanging on for a little while. It's just going to keep hanging on. I'm going to introduce, well, no, I wasn't. I was going to do something else, but we'll just use brackets. I'm going to go ahead and put the real parts together. So x minus 3. A negative times a positive makes that negative. Again, a negative times a positive, that's going to be negative I. So all of that goes together. Okay. Then I'm going to do the same thing afterwards. This is going to be x minus 3 again. And a negative times a negative is going to be a positive. And close this. Now I'm going to go through and I'm going to multiply all of this out. Now I know that it looks rather complicated, but think of it like this. X minus 3 is a term. X minus 3 is a term. Negative I is a term, and then I is a term. So x minus 3 and x minus 3, I and x minus 3. So I still have 4 terms. So this is going to give me x plus 2. So I'm going to do x minus 3 times x minus 3. I am not going to multiply that out just yet. I'm just going to write it as x minus 3 squared. So I'm doing x minus 3 times x minus 3. I'm doing the distributive property. So this is just going to give me x minus 3 squared. Now, when I multiply this, when I do negative I times x minus 3, and positive I times x minus 3, they are going to cancel. Negative I times x minus 3 and I times x minus 3 are going to cancel. I'm not even going to write that down. I am going to do negative I times I, and that's going to give me negative I squared. So it looks complicated. I'm still doing the distributive property. I'm still doing the box method. You don't have to write this down, but for those of you doing the box method, if I were to set this up, I'm doing x minus 3 minus I times x minus 3 plus I. Okay, so I'm doing x minus 3 minus I, x minus 3 plus I. So x minus 3 times x minus 3 is giving me x minus 3 squared. These two boxes are going to cancel out, and I times negative I gives me I squared. Now let's keep right on working. So it's going to give me x plus 2. If we do box method or distributive property with x minus 3 times x minus 3, it gives me x squared minus 6x plus 9. I squared is equal to negative 1. So this is equal to negative 1. So a negative times a negative makes that positive 1. I did not literally work this out. This is just box method distributive property. You're doing x minus 3 times x minus 3. It gives you x squared minus 6x plus 9. Okay, almost finished. I need to combine my like terms and then multiply one more time. So 9 plus 1 gives me 10. And the last thing I need to do is the distributive property. So x times x squared is x to the third. X times negative 6x is negative 6x squared. X times 10 is 10x. 2 times x squared is 2x squared. 2 times negative 6x is negative 12x. 2 times 10 is 20. Okay. Combine like terms, and our final answer should be x to the third. Put those together, I got negative 4x squared. Put these together, I got negative 2x. And then my number comes down. This was a very hard problem, a very challenging problem. What I want you to gather from it is that imaginary numbers come in pairs. So we had 3 plus I, so we had to include 3 minus I. I also want to take away from this is that to do your imaginary parts of the problem first. So we did the imaginary parts because something is going to cancel and then it's going to make it all real. So if you get stuck on this one, it's okay, but you should definitely make sure that you're able to do the ones like this where you multiply it out, and then problems like number 1 and number 2.